Good afternoon. Today, we will be discussing a project that explores the economic principles behind remote work trends using data analysis and machine learning models. With the
Mhm.
rise of remote work, particularly during and after the pandemic, it's important to understand the factors that include the shift and its implications on the economy. To analyze this, we utilize the dataset from Kaggle, which contains information on remote
Mhm.
work patterns, employee productivity, and various economic indicators. So here we started by exploring the dataset, which includes variables such as employee demographics, job types, industry sectors, productivity metrics, and economic factors
Mhm.
like wages and employment rates. The goal was to identify key trends and relationships between these variables, particularly how remote work is impacting productivity and economic outcomes. Our approach involves cleaning and pre-processing this data, followed by
Mhm.
feature selection to identify the most important and relevant variables. We then applied several machine learning models, including linear regression, decision trees, and clustering algorithms, to uncover patterns in the data. These models helped us predict productivity
Mhm.
levels based on factors like job type, industry, and remote work frequency. The analysis revealed some interesting insights. For instance, certain industries like tech and finance saw higher productivity levels with increased remote work,
Mhm.
while others, such as manufacturing, experienced a decline. Additionally, we found that remote work was more effective in high income brackets, suggesting a correlation between job type and visibility of remote work. So now Mars will be explaining the code
Mhm.
behind machine learning and the data analysis which we have.
So good morning, sir. Sorry. So good morning, sir. In this project, we have got the data of 2 years, 2020 and 2021. These years were mainly important because these were the times when the most people were working from home due to COVID-19. Now, in this project, we have merged both the data set into one file. And then we have done exploratory data analysis. That is the main, that is the prerequisite for our machine learning model. So, so first we have imported some libraries for our machine learning model. Then we have defined all the columns for our model for our data set. Then we are loading our data set into our data frame called DF. Then we are doing the exploratory analysis on our data set. Then we have divided the data set into two parts: training data set and testing data sets. Since we are using a supervised machine learning algorithm, we'll use training data set to train our machine learning algorithm. Then we'll use our testing part of data set to test its accuracy upon the unknown inputs. So we have done this here. Then, so in this in this project, we are using ensemble learners. Ensemble learners are those learners that use different smaller parts of different types of machine learning algorithms to make a better and more accurate machine learning algorithms. So the one that we have used is known as random forest classifier. So so we have imported it here in this part of the code, and we have used it to predict the output. Then we are using this model to then we have used this model to predict our values. These are the values that we have got, and we have calculated the accuracy upon the testing data. So the accuracy that we are getting is for we have categorized the accuracy upon two different categories. Zero, the persons that have the preference to work from home to 0 to 3 days, and another group of people that have their set their preference to work from 3 to 5 days remotely. So the first result that we have got is about precision. So precision is about the positive accuracy of our result. It is a ratio between true positive predictions to the total number of predictions. Then the second column is about recall value. Recall is also known as sensitivity. This is the ability of a model to capture all positive instances. Then the third column is about specificity. It measures the ability of the model to identify negative cases correctly. Then the second last column of our result is F1 score. This is the harmonic mean of precision and recall. Then the fifth column is about geometric mean. It is same as similar to F1 score. It is the geometric mean between our precision and recall. The second last is about index of balanced accuracy. This is a matrix that adjusts the balance accuracy by penalizing the misclassification of minority class severely. And the last column is about support. This is the number of actual occurrences of the class in a specified data set. This quick. Then exceeded 5 minutes. What were the? Just read out the first two. No, no. Ooh. Go advance. How fast I have to go? We share. Stop sharing. Stop sharing. Stop sharing. Just stop. 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 Please stop. Stop share. End. And for all.